Hi students, welcome back to physics class. In this class, I am going to teach 11th standard physics, lesson number 5, kinetic energy in rotation. So consider a rigid body. So already I thought, what is rigid body? Rigid body means never change its shape and volume, and external force applied on it. That body is said to be rigid body. So that rigid bodies rotate about the axis with angular velocity omega. So this is a rigid body. The rigid body is rotate about the axis with angular velocity omega. So generally body is made up of large number of particles. So consider ith particles, the distance Ri from its center. So kinetic energy of ith particle, kinetic energy Ke I is equal to half mI square. So by relation between linear velocity, angular velocity. So this equation represents kinetic energy of ith particle. So we are considering ith particles of mass Mi, the distance Ri from the origin O. So kinetic energy of ith particle Ke I is equal to half mI square. This equation 1. So this relation obtained relation between linear velocity, angular velocity. So Vi equal to Ri omega I. So substitute this Vi value in this equation. We obtain the kinetic energy of ith particle is equal to half Mi Vi square equal to Ri square omega I square. So this is kinetic energy of ith particle. So total kinetic energy of the whole body is equal to sum of kinetic energy of ith particle. So kinetic energy K is equal to half summation, that is sum of Mi Ri square omega square. In this equation, sum of Mi Ri square is a moment of inertia I. This I is represent moment of inertia. I is equal to summation of Mi Ri square. So total moment of inertia of the whole body, rigid body. So kinetic energy rotational motion Ke rotational is equal to half I omega square. This is kinetic energy rotational motion. This is equation 2. This equation 2 represent kinetic energy in rotational motion. Ke rotational is equal to half I omega square. So here omega is a angular velocity, I is a moment of inertia, K is a kinetic energy rotational motion. So kinetic energy in rotational motion is analogous to the expression for kinetic energy in translation motion. Ke is equal to half mv square. This equation is kinetic energy in translation motion. So next, relation between rotational kinetic energy and angular momentum. So angular momentum of rigid body L is equal to I omega. L is a angular momentum, I moment of inertia, omega angular velocity of rigid body. So kinetic energy rotational motion Ke rotational is equal to half I omega square. So in this equation, multiply and divided by I, we obtained kinetic energy rotational motion equal to 1 by 2 I into I square omega square by I. So finally I of I omega whole square by I. So I omega equal to L. Substitute this L value in this equation. We obtain K is equal to L square by 2I. This is the relation between kinetic energy, rotational motion, angular momentum.